Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. At this point we have got almost everything we need in order to construct any type of texture from one or more source images. Our texture importer certainly supports all kinds of textures, and the texture editor can view any type of texture that has been constructed. However, we still need some way of telling the importer how it should assemble the source images to construct a certain type of texture. More specifically, we need to be able to configure the import settings before importing images. In order to prepare for this functionality, I'd like to set us up properly for an expansion of what we already have. This involves doing a bit of code cleanup, followed by adding a new control to the content browser. With this new control, we can choose between importing assets using their default settings or by using an import settings configurator screen. Today's video is pretty much a series of little improvements and code cleanup for the texture importer and texture editor. Let me start by fixing a little bug which happens when we press the minimize or maximize button of the texture editor window. As you know, we can use keyboard key combinations such as Ctrl+ and Ctrl- to zoom in and out of the image. However, when we press the window buttons, the keyboard's focus will shift to these buttons and therefore the texture editor won't receive any keyboard events. This can be fixed easily by setting the focusable property of the window buttons to false, which we can do in the style of these buttons. We have two of these styles. One is defined in primal window style and the other one is defined in primal dialog style. This has a drawback that we are no longer able to minimize or maximize our window by moving the focus to these buttons with the tab key and pressing enter. However, I can't think of a good reason to do it that way other than if your mouse isn't working, in which case you are probably not going to work on your game project anyway. Now I can keep using the keyboard keys for zooming even after I clicked the maximize button. Next one is the channel selection shader. Initially, I wrote this part as separate calculations for each channel so that it's easier to understand. Now we can write it in a single line of code by using a vector instead of scalars. We can do this easily by using a float3 and swizzle the components of mask and inverse mask vectors. Of course, we need to recompile this shader, so I have to go and find the FX compiler again, hopefully for the last time. Now we have a new compiled shader file and we can see that it works just the same. Good. We don't want the editor state to be set from outside the class, so we make this property private. This is the case for the texture asset property as well. However, we forgot to make the geometry editor state an asset private. So let's do that now. Okay, next in texture view, I'll make these fields private explicitly. And in texture editor view, these commands should be read-only properties. In texture view XAML, we can merge these two canvases and only use one. So this one's for the checker background image that we see when a texture has a transparent background. We can add a border and use this checker image as its background and display the texture image within this border. Also, I'm not happy about how pan and zoom are handled right now. They are bound to view model properties, but we are setting these in the code behind, and we wrote this code in order to handle the case when pan offset and scale factor are set by anyone else. Here we are attaching and detaching event handlers and such, which is not ideal. A better way of doing this is to create dependency properties for pan offset and scale factor and use them instead of view model properties. So we register a pan offset dependency property, and we are going to write a function to handle whatever needs to be done when the pan offset changes. And I'm going to add another one for scale factor. Now whenever the pan offset is changed, we need to run this code. However, now it's easier because we get the old value as well as the new value of pan offset. We can use them to calculate by how much the background grid has to shift. In addition, since we are already calling this function, we can also shift the texture by setting canvas left and canvas top attached properties for the border that contains the image. When the scale factor is changed, if the background grid has a scale transform, we set its value to the current scale. Now we don't have to bind to scale factor anymore. We only have to add a scale transform here. Similarly, we don't have to bind to pan offset, and we can remove this line. Now we don't need this anymore, and we can remove it as well. The old pan offset field can also be removed. We can remove the pan offset and scale factor properties in the texture editor view model since they are not used anywhere. Well, they are actually used in the texture view's code behind, but now we can use the dependency properties instead. So I'm going to remove all references to the view model and use pan offset and scale factor directly. We can see that it works the same except for the zoom label, which is not appearing anymore. Looking in the output panel, we can see that we have got a binding error that tells us it can't find the scale factor property. As you can see here, the zoom label is still bound to the scale factor, which indeed doesn't exist anymore. So we have to get this value in some other way. The easiest way to do this is to find the user control we are in, which is the texture view, and bind to its scale factor dependency property. And now it works again. I forgot to also show the zoom label when we call the zoom function with the same scale. This is needed when we only want to see what zoom level we are in without actually zooming in or out. This should be public, I think. Since 3D textures can have a different depth per MIP level, we need to adjust the depth index whenever the MIP index is changed. This can be an object, I guess this can't be public since it's already a public interface property. Great. The next issue that we have happens when we try to open a texture that uses sRGB color space. Here we can see that this texture has a BC7 sRGB format, for which we are trying to get an enum description. However, our enumeration here doesn't include any sRGB formats, and therefore trying to call this getDescription extension method throws an exception. We can ignore this exception and continue, but then the format field remains empty. There are a few ways to solve this issue. For example, we could add descriptions to our copy of the XGI format here and only use this enumeration for displaying texture details. We can also only add descriptions for sRGB formats and use this enumeration whenever the texture is sRGB. As you can see, I went with the second solution. So now when we want to get the format name, if the texture uses block compression and is not sRGB, we use BC format enumeration. Otherwise, we use the XGI format. As you'd expect, we need to somehow pass this information from the C++ texture importer to the editor. This can be done relatively easily by defining a new flag in our texture flags. Then we do the same things we did for the other flags. Oh, let me fix the typo here. Okay, so now we have to add the same flag in the C++ side. The enumeration is a part of the engine, so we need to add it in content to engine texture flags. We can set it in the texture importer if the imported texture uses sRGB color space. Let's try and import a new sRGB texture. I'll also remove the FX compiler. It works, but it's not showing as sRGB. What gives? Oh, I didn't change this description after copying it. Okay, now it should work. Cool. The next improvement is about limiting the maximum number of 2D texture array elements and 3D texture dimensions. Right now we support any number of textures with a size up to 16K pixels. In addition, the texture library that we are using to create our textures doesn't have a problem with arbitrarily large textures. However, looking at Direct3D 12 resource limits, we can see that although we are allowed to create and upload 1D and 2D textures with a size up to 16K, the number of elements in the texture array is limited to 2048. On top of that, if you'd create a 3D texture, it can't be bigger than 2K pixels, even if it has a depth of 1. So I'd like to add these requirements to our texture validation method and fail texture import if these limits are exceeded. First, we'll make sure that the texture size is not larger than 16K. Because we need to validate array size and 3D sizes, we have to pass this information in method parameters. Then in case of 3D textures, all dimensions should be smaller than max 3D size. And for 2D texture arrays, we check if the number of elements is lower than max array size. We return false only if the import should fail. Otherwise, it's just a warning for the user. When we call this method after import and it returns false, then the import also fails. While loading a texture, we can only have warnings, so this shouldn't ever return false. And these should be all errors, obviously. While we are working on validation, I'd also like to give an error if we try to create a texture cube with a number of images that's not a multiple of 6. We add a new error code for this and return this error if the number of source images is not a multiple of 6. Here we already have an assertion, but it should actually fail if array size is a wrong number. In this case, we set the error code and return an empty scratch image. Then we simply add the new error code with its description in the editor side in order to communicate it to the user when it happens. As I mentioned in the video where I wrote these functions, I'm not fond of having static local variables like this, and we are also leaking resources by not freeing these DLLs after we are done with them. Granted, we only need to do so when the application is shutting down, but it's still technically a leak. So let's spend a few minutes to do it properly. First, I'll add global variables for the XGI and D3D11 modules. This way we can release them later. When this function is called and the XGI module is null, we can try to load the DLL. We return an empty array if it failed to load it. If it succeeded, we can use it to get a function pointer to create the XGI factory 1. Again, we return an empty array if that failed. The rest of the function remains unchanged. We do the same exact thing for the 3D11 module. We load the 3D11 DLL and get a function pointer to the 3D11 create device. Then we can use it to create one or more devices. Oh, this should be modulo 6. I don't know what happened there. Alright, now we need to unload those DLLs when we are shutting down. We don't have to do this per se, as Windows will automatically clean up after us when the process is shut down, but it's a good practice to do this. If someday we would like to reload the Content Tools DLL, for example, then we would leak resources every time we would do so. Of course, there should be a way for the editor to call this. Instead of exporting this function, I'll add a single shutdown function for the entire Content Tools. Then we can call any functions that are needed for cleaning up and releasing resources from this central function. So I added a new CPP file where we can put general functions that apply to everything in Content Tools DLL. Here I included tools common header and forward declared the shutdown function from texture importer. We can add an export Content Tools shutdown function where we call shutdown texture tools. Next, we can import this function in Content Tools API in the same way we have done before. Finally, we call this method when the main window is shutting down. Let me also move this constructor down here. Okay, let's see if we can do a few more small improvements before we can wrap up for today. One thing we can do is to hide the alpha channel button when the image format doesn't have an alpha channel. We can bind the visibility of this button to has alpha property and then use a boolean to visibility converter to make it visible if it's true and collapsed when it's false. This converter is part of WPF, so we don't have to write it ourselves. And finally, I'd like to add a little help section to the editor to inform the user about various interaction possibilities of Texture Viewer. This is a simple border with an expander which contains a list of text blocks with information. We'll set the border opacity to 1 if the expander is expanded or the mouse is hovering over this border. Then we add a nice question mark header and a stack panel for text blocks. We also set the default color for the text. Then we can add a text block for each interaction we want to describe to the user. Now we can see a small button here which we can click to expand, and it will display the help text. Unfortunately, it blocks the mouse clicks when we try to pan the image, but I'm sure you can think of a solution for it. We can also see that the alpha channel button is hidden when we open a grayscale image. And the geometry editor also still works, which is great, and with that we have come to the end of today's video. The code that we wrote today wasn't really exciting in any way, but I've learned that when I take a few hours every now and then to do these kinds of code cleanup and small improvements, the future me will be a lot happier and more grateful for not having to deal with a bunch of janky functionality that would otherwise accumulate over time and slow down development. So I hope you enjoyed watching this video, and as always, thank you so much for joining me, and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!